So now let us continue with part 2 of this particular question which we are discussing. In the first part, we found the derivative of the function f of x equals to x to the power of 1 over 3, x minus 4 to the power of 2 over 3, and the derivative was 3x minus 4 divided by 3 times x to the power of 2 over 3 times x minus 4 to the power of 1 over 3, right? So that's the part 1 which we did, right? So we are talking about this particular derivative, right? And we also found that the function is increasing in some interval, that's the portion, and it is only decreasing in the interval from 4 over 3 to 4. It has a maximum at 4 over 3 and minimum at 4, right? So we'll continue from here, analyze the second derivative now. So the idea in part 2 is to find point of inflection, right? That is what we need to find, and for that we need to analyze the second derivative of this particular function, right? Now to find the second derivative, you could always start with this function and find the second derivative. However, what I'm going to do here is to use logarithms to find the second derivative, right? So it helps when you apply logarithms to simplify such a complex expression, right? So what we will do here is we'll take ln. You could write log or ln as you wish. I prefer ln. So ln of f dash x. So that is what I'll take. So I'll take ln on both the sides. So log properties, I hope you remember. So when you multiply, you add, and when you divide, that part becomes minus, right? So when you take ln of the whole expression, which is in this case 3x minus 4 over 3 times x to the power of 2 over 3 times x minus 4 to the power of 1 over 3, what do you get? So what you get is that you get ln 3x minus 4, and these parts are like negative, right? So minus ln 3 minus this part. So the power comes like this, 2 over 3. You may review this, how to use logarithms to find derivatives. Okay, and then this is ln x, and for that part it will be minus, since all is in denominator, 1 over 3 ln x minus 4, right? So I hope this part is clear. And those of you who are finding this part difficult, you can continue with the quotient rule which you've learned, right? No problems. We did the quotient, right, product rule earlier in the first part, but quotient rule is very common. So we'll do this, right? Okay. So when you take derivative of this, then what do you get? Derivative of this function will be 1 over the function itself, which is the derivative, right? Times the derivative of this function. So we get the second derivative. Right? So that's a tricky part. But it helps to simplify the whole expression. You will soon see how. Alright. We could have done it with quotient rule also. Anyway. But I hope for some students that will be interesting. Okay. So the derivative of ln 3x minus 4 is 1 over all this. 1 over 3x minus 4 times the derivative of this, which is 3. Is it okay? Minus. This is a constant. ln 3 is a constant, so derivative will be 0. And then we have minus. So we have 2 over 3 here. And the derivative of ln x is 1 over x, correct? So this is what you get. And the next term here is minus 1 over 3. So it's a constant 1 over 3. Derivative of x minus 4 is 1 over x minus 4, correct? So that is what you get. It is, as you must have done quotient rule, it is very, very simple expression to work with, right? Now we can take a common denominator and then really figure out what this expression could be, right? So remember, we have here the derivative in denominator. It will go in this side and get multiplied. So this expression is going to be very complex soon, right? So now let's see what is the common denominator, right? So let me write down a common denominator here. So as far as the numbers are concerned, we have 3 times 3, which is 9. So let me write 9 here. and these are the factors which are 3x minus 4 times x, right? Okay, x times x minus 4, okay, x minus 4. So these are the three factors which will get into the denominator. So 9x times 3x minus 4 times x minus 4. In the numerator, this 3 will be multiplied by these two factors, right? So we have here is 3 times 3x times 3 times x minus 4, correct? 0 is 0, so we'll not bother about it now. Minus, here we have 2 times these two factors, correct? So 2 times 3x minus 4 times, this is 3. Okay, because we just multiplied all of them, right? I could have just taken 3. I took 9. Okay, that's fine. It makes job simpler. It doesn't matter. We'll cancel later. Okay, so where was I? So we are multiplying this by where in this part. Okay, that's fine. So 2. So we have multiplied this 2 by that factor, which is 3x minus 4, and this factor, which is 3 times x minus 4. And now minus the third term, 1 is in the numerator, will multiply by 3x times 3x minus 4. Okay. Well, I could have taken 3 instead of 9. So slight lower terms. You could do that, right? So you could do that anyway. So we'll continue with this. Fine. Now we need to just multiply all this. That's a very tedious exercise. This pen is, we'll change the pen so that, you know, I get more room to write. Okay. So we'll just multiply. 3 is 27, and x times x is x squared. So we have 27x squared, and then 27 times 4. I need a calculator now. Okay, we'll multiply all this and then see what we get. So 27 times 4 is 108. So we get 108x, right? So we have minus 108x. You can pause the video, do your calculations, and then get back with me. So we have 3 times 2 as 6. We'll write 6 here, and I'll do it in 2 steps. 3x squared minus 12x minus 4x plus 16. Okay, and this one is 3 times 3 is 9. 9x squared plus 4 times 3, 12x. Is it okay? That's fine. Okay, then divide by all this, which is 9 times 3x minus 4 times x minus 4. And now we'll open this bracket and then again simplify. 27x squared minus 108x. This 12 and 4 is 16, right? So first multiply these. 18x squared, and then we have 16 times 6. Okay, 16 times 6 is 96. So we'll write 96x with a negative, and negative becomes positive, so 96x, and then 16 times 6 again 96. That's good. And we have minus 9x squared plus 12x divided by all this. Let me rearrange this time. 9x 3x minus 4 times x minus 4. Okay, now it's time to simplify. This is the best step. So what do you get here? 27x squared. So we'll just look into the x squared terms. So let me use calculator so that we don't make any mistakes now. So we have 27 minus 18 minus 9. So we do 27 minus 18 minus 9, which is 0. Okay, so the x squared terms are 0. They all cancel out. Okay, so we've taken care of these three. Okay, 27, 18, and this. Fine. Now let's take care of the x terms, which are 108. Okay, so we have 108, 96, and 12x. Okay, 108 is negative, and 12 and 96 is positive, which adds up to 108. So that is also 0. Okay, good job. So that is also 0. So I don't have to bother much. We are left with minus 96 now, correct? So okay, so we have left with minus 96. That turns out good. Divided by 9x times 3x minus 4 times x minus 4. We are running out of space here. So what I will do here is, now we'll write the second derivative here. F second derivative, multiply by the first derivative. So times the first derivative. Now what is the first derivative? That is my first derivative. So instead of writing f dash x, I'm going to write this whole derivative, saving some space only, okay? So what I'm doing here is copying the first derivative from here, which we derived in part 1, and I'll just put it here. Is it okay? I'll just put it here. That is what I'm doing at this stage, which is 3x minus 4 divided by 3 times x to the power of 2 over 3 times x minus 4 to the power of 1 over 3. Okay, all this. So now we'll simplify this. Should I write here or should I? I'll simplify and write down the final answer here. So like this. Okay. So let us see what we can simplify now. So 3x minus 4, 3x minus 4 cancel out. I could divide 96 by 3. Okay, so we get 32 here. Okay, that is good. And then we can combine these terms, right? We can combine these terms. Good. So we'll write down our final expression of second derivative, which is right here. Minus 32. Okay. 9x. Now x is to the power of x plus 2 over 3, that is 5 over 3, right? So 9x to the power of 5 over 3, and then we have x minus 4 to the power of 1 plus 1 over 3, which is 4 over 3. Is it okay? 4 over 3. So that is the second derivative. So we get the second derivative of the function, and this is it. This is it. Perfect. So let me highlight the second derivative. Now we'll use the second derivative to figure out the exact shape of the graph. Good. Now what do you see here in the second derivative? So let me make some room to analyze. I don't want to run into another sheet. We'll kind of close it here, okay? So what you really analyze here is, let me do it in this box. Good job. Okay. Now, okay. So here we find that the second derivative is not defined at x equals to 0 and at x equals to 4, right? So what we see is that f dash x does not exist at x equals to 0 and x equals to 4, right? So these are critical points. These are critical points to analyze for point of inflection. That's the whole idea. Is that okay? Point of inflection is a point where the concavity changes, right? So that's just a reminder. I know you all know about it. So that's what we're trying to analyze. So concavity, if my second derivative is positive, it is concave up. If it is negative, it's concave down, right? You remember that. So what I'll do is, we only 2 points to analyze. So let me just sketch this here in short and say these 2 points are 0 and 4. So we have, let's say this is 0 and 4. Okay. So what we have here is 0 and this is 4. So we'll take test points on either side to analyze this particular function. So test point on the left side could be minus 1, and we can take 5 here, correct? Good. So running out of space, that's the only issue. Otherwise, taking up a new page and sketching, I think could have been a better idea, but I think I'll close it here. Okay, so we have this expression. So you see minus 32. So that minus 32, where should I write? So minus 32 is, let's say, minus 32. Okay, so we'll do, sorry for all this. Okay, think like this. Okay, bear with me. So we have this minus 32. So minus 32 is always negative. So we'll make this negative. Good job. Now x to the power of 5 over 3. Now if x is negative, this is negative, so it is negative. If x is positive, it is positive. And the next term is x minus 4 to the power of 4 over 3. Since this is even power, it is always positive. Is that okay? So when we do product of all this, what do we get? So when you do product of all this, let me write that on the top, right? Because I want to sketch my final function here. So we get positive here, two negatives. One negative means negative here, and then again a negative here. This is what we get, right? So this is what we get. So negative and positives, what do they mean? So positive means concave up, correct? Positive means concave up. So concave up. So we'll say concave up. The graph will be concave up in this portion. And in these portions, the graph is going to be concave down. Is it okay? Concave down. Negative. Second derivative is what we are analyzing. So that means we have point of inflection at x equals to 0. Perfect. And at other points, we do not have point of inflection, right? So there is no point of inflection at these points. But what you also know from the first derivative, from this point, it was undefined. Since it was undefined, we have cusp here. We are not saying it from this aspect, right? Okay. Anyway, so we found that there is a point of inflection at x equals to 0. Now we have all our information to sketch the graph. So let me pull out the values which we learned in the first part. So let me just get that back to you now. So we found that the graph of this function is increasing from minus infinity to 4 over 3 and 4 to infinity. Decreasing from that interval, maximum is 2.1 at 4 over 3, minimum is at 4, which is 0, right? This is what we learned. So if I put all these things together, okay, do really is I'll just pull out a new sheet and then we'll sketch the final function in a new sheet. Okay,